Welcome to Cloud Computing Debate number 5, The Con Perspective. Team members Shane Collier, Anusha Mova, and Keith Zhang. The premise is within the next decade, web-based applications and cloud computing will almost entirely replace personal, i.e. desktop and laptop computing. The time frame that we're considering is defined by the premise within the next decade, indicates a period of 10 years from 2014 as opposed to the end of the following decade, December 31st, 2029. First and foremost, the cloud is a business model. It facilitates organizational agility, reduces administration overhead, provides scalability, mobility, hardware independence. It also reduces the time to market while shifting capital expenses to operational expenses. So what is cloud computing? According to the National Institute of Standards and Technology, cloud computing is defined as having 5 essential characteristics, 3 service models, and 4 deployment models. The 5 essential characteristics of cloud computing are on-demand self-service. You choose what you need, how much you need, and when you need it, and provision it yourself. Ubiquitous network access. Your services are available when and where you need them, on your phone, your laptop, your desktop, or your server. Location-transparent resource pooling means that without any need for intervention, your servers are balanced, data distributed, whether around the country or around the world. Rapid elasticity, 30,000 hits today, 5 million tomorrow, 10,000 the next day. Rapid elasticity allows your services to adjust with the demand. Measured self-service with pay per use. Just like with the water and electricity in your home, you only pay for what you need. Service models. Software as a service. We're familiar with this. Gmail, Hotmail. Platform as a service. Want to deploy your application without the overhead of managing a server, keeping it up to date, all the patches applied? Platform as a service is there for the developer. Infrastructure as a service. Need to move large segments of your production infrastructure to the cloud? Infrastructure as a service provides you that opportunity. There are 4 central deployment models. Public cloud is a shared online cloud computing environment based on multi-tenancy. In a private cloud, companies use their own hardware and software to bring services online, both internally and externally. By using the hybrid model, a combination of public and private clouds, a company can keep sensitive data close while leveraging the economy of scale in the public cloud. Community clouds allow organizations with a shared need or a specific regulatory requirement to pool resources to meet those needs. Examples include government and educational organizations. Perhaps one of the best ways to define cloud computing is to review what it is not. It is not new. The concept was initially introduced in 1966 in Douglas Parkhill's book, The Challenge of the Computer Utility. It is not simply the contemporary implementation of online hosting or a component offered as part of a service-oriented architecture. These do not support the essential 5 characteristics. They lack the sophisticated automation and self-service needed to be genuine cloud solutions. Finally, cloud computing is not a technology. It is implemented using technologies. This is why the leading vendors such as Amazon Web Services and Microsoft's Azure have very different architectures. This leads to vendor lock-in and reduced mobility between vendors. The premise as stated is false. The basis for this falls into 2 categories, non-technical and technical. Non-technical basis includes governance, organizational change, and psychology. Cloud solutions must comply with industry-specific legal rules. For example, the Payment Card Industry Data Security Standard, PCI DSS, must be followed with transactions involving credit and debit cards. Each country has different laws and rules. Which nation's rule has priority? Intellectual property laws? Does data have to be stored in the country where it is served? Who owns the data as it changes from country to country? The laws are not keeping up with the rate of technological change, nor is the situation likely to improve over the next 10 years. The state of Florida can't pay. After an 18-month effort, it was unable to put a $6 a month ongoing charge on a P-card. Eventually, the project was abandoned altogether. Organizational change, overcoming momentum, massive infrastructure investments that have to continue to be justified. Existing staff with traditional roles will shift. People need to stop seeing themselves as system administrators and need to start seeing themselves as managers of services. Some won't make the change. How the IT organization is funded from within the firm, fixed budgets versus bill-as-you-go approaches to internal customers, leads to radical change regarding the processes of software development, testing, deployment, and operations. Psychology. The restricting effects of awareness. If you already know something to be true, you stop looking for alternatives. If you already know the answer, you stop looking for answers. If you investigated the cloud 3 years ago and it was insufficient, you tend to maintain that perspective, despite a high rate of evolution. Normalcy bias states that things tend to continue as they have. If something has not happened before, it's not likely to happen. The cloud has not been a challenge. Therefore, it's not a challenge now. Our infrastructure investment stands as a barrier to entry to our competitors. We spent $100 million building up a large infrastructure. Anyone who chooses to compete with us must also therefore spend $100 million spinning up a large infrastructure. Unfortunately, the nature of the cloud means this simply is no longer true. Next, the technical basis for our position.
Hi everyone, I'm Anusha and I'm going to talk about the issues in cloud computing. Cloud computing is definitely a flexible and cost-effective platform for IT services over the internet. However, it presents an added level of risk because essential services are often outsourced to a third party, which makes it harder to maintain data security and privacy and to ensure the availability of services. There are various data-related concerns that arise. Loss of control over data is one issue. There is a lack of transparency for the customer as to how their data is being stored, where is it being stored, and how is it being processed. The insecure disposal of data is another issue. Cloud service providers often change out hardware without notifying the users. So if it's not professionally done, then the equipment will still hold some confidential data. Also, data backup may sometimes be done by untrusted third party vendors. Data leakage happens when the data gets into the wrong hands while it is being transferred, stored, audited, or processed. The next one is denial of service. Uh, this is a phenomena where a malicious user will take all the possible resources and the system will no longer be able to process any user requests that are legitimate because the resources are not available. This is more like a Russia traffic gridlock. Brian and Allison launched cloud-based DOS attacks to one of their clients in order to test its connectivity with the help of Amazon CC2. They spent $6 to rent virtual servers, used a homemade program to successfully flood their client's server, and they made it run. The next issue would be with the insecure interfaces and APIs. The cloud providers, while providing services, they offer those services through APIs. So the security of cloud is dependent on the security of the API. And there can be some problems here like weak passwords, insufficient authorization checks, or improper input-output validations. And then brute force attacks could happen due to this. Brute force attack is a technique to break passwords. Thomas Roth, a German researcher, managed to crack a WPA-PSK protected network by renting a server from Amazon CC2. In approximately 20 minutes, they fired 400,000 passwords per second into the system, and the cost was only 28 cents per minute. Vulnerabilities in virtual machines is another issue. Sometimes resource allocation is not properly managed. Also, there may be uncontrolled migration of VMs. VM snapshots are done and VMs are copied in order to provide flexibility. However, this could lead to data leakages at times. A significant here is VMs have IP addresses that are visible to everyone in the cloud. So hackers can easily figure out where their target VM is and plan their attacks. This is actually called cloud cartography. Shared technology vulnerabilities is another issue that I would like to address. Cloud service providers deliver their services in a scalable way by sharing infrastructure, platforms, and applications. A fault in any single component could sometimes compromise not just one customer, but the entire cloud could be at danger. E-crime is the last issue that I would like to talk about. E-commerce platforms are hosted on cloud and they are subject to attacks. There is a high risk of exposure and misuse of payment data. My friend would continue on from here.
Now I'm talking about the inconsistency of cloud computing. As we know, cloud computing are all based on the internet, so it will have some problems. The first is the possible downtime without internet connection. Cloud computing is totally dependent on internet connection. When the internet connection or the internet network is down, cloud services are down as well. Connect run slow. If the connection runs slow, when your service will also run slow, and the output of your enterprise get affected. Your entire system or operations may become idle if you do not have the necessary backup or alternative internet connection. They'll have some problem of data by using cloud computing. First is data loss. Data loss is a very serious problem in cloud computing. It is related to both vendors and customers. If the vendor closes due to financial or legal problems, there will be a loss of data for the customers. The customer won't be able to access those data because data is no more available for the customers as the vendor shut down. The second problem is data location. Customer could not know where is the data. It could be located anywhere. When it comes to location of data, nothing is transparent. Even the customer don't know where is his own data are located. The vendor does not reveal where all the data are stored. The data won't even be in the same country of the customer. It might be located anywhere in the world. Here I will cite two examples to support my idea. The first is Amazon. Amazon Web Service is a prominent cloud computing provider in the country. The department is the fastest growing department of Amazon. However, in October 2012, service fell for a while. Users who had their files stored in Amazon Web Service were unable to access their documents. Jimmy Tan said that, "We don't think the cloud is enterprise ready. Are you really going to trust your corporate jewelry to these cloud providers?" The second example is the LinkUp. LinkUp is an online storage service company. It shut down on August 8, 2008 after losing access as much as 45% of customer data. Now I'm talking about the personal computers. PC have a lot of advantage. The first is that it have better performance. PC have less reflection time compared to the cloud computing. It will be more secure and more consistent. There is no requirement for the PC to use a network. Also, the costs are more predictable and ongoing costs are minimal. The most important is that when you travel, you don't need that network and you also can do your work. This is the portable for the PC. Finally, PC have the customized hardware configurations. In the conclusion, although cloud computing can be seen as a new phenomenon, which is set to revolutionize the way we use the internet, there is much to be cautious about. However, It must be very careful to understand the security risk and the challenges posed in utilizing new technology. Cloud computing is no exception.